So same directions. You can consider this series a function. The series from n equals 0 to infinity, -1 to the n, x minus 3 to the n power divided by 2n plus 1. So x is like your input variable here. And we want to figure out, okay, for what values of x does this series converge, if it converges for any of them at all? And with most of these problems, you're going to use the ratio test, maybe the root test, but in this case, definitely the ratio. So the ratio test always starts out the same way. You're going to find the absolute value of a sub n plus 1 over a sub n. Now, so this is a sub n. What part of a sub n can I lop off because of the absolute values? -1 to the n. Just keep life simple. The absolute value splits up over multiplication and division, so you can lop that part off. In other words, you could separate it to be the absolute value of -1 to the n times the rest of that stuff. And of course, the absolute value of -1 to the n is just 1. So what's left then is the absolute value of x minus 3 to the n power divided by 2n plus 1. Oops, sorry, I got a little bit of tunnel vision there. We're finding a sub n plus 1. So what does it become? Not x minus 3 to the n power, but x minus 3 to the n plus 1 over, all right, 2 times the quantity n plus 1 plus 1. If you multiply it out, what do you get? 2n plus 3. Is everybody okay with that? So what I just wrote down is a sub n plus 1. Does everybody agree with that? Okay, now let's divide by a sub n by multiplying by its reciprocal. So what's the reciprocal of a sub n? Well, just, whoops. What goes on top? 2n plus 1, right? And then on bottom, bless you, x minus 3 to the n power. Okay, so everybody agrees that's the absolute value of a sub n plus 1 divided by a sub n. Okay. Well, let's simplify it a little bit. What do you get on top? Notice you have base x minus 3. So when you divide x minus 3 to the n plus 1 by x minus 3 to the n, what's left? Just x minus 3, yeah, to the 1 power. And then how could we reorganize it? Let's make it x minus 3 quantity. And then we still have a 2n plus 1 as a quantity. And then I'm going to write it like this, divided by 2n plus 3. Everybody agree with that? Not that you really need parentheses there because the division bar is a grouping symbol, but that's okay. Yeah? Okay. So now we need to see what, this is really a formula for the nth term of a sequence, right? We need to find what this thing does as n goes to infinity. So again, I'm going to use the limit notation, LIM. The limit as n goes to infinity of x minus 3 times 2n plus 1 over 2n plus 3. First of all, what could I pull out there? So it's the limit of this whole thing. What can I pull outside? Yeah, the x minus 3, and this is when the limit exists, I can pull out the x minus 3 because it's not x goes to infinity, it's n, right? So when the limit exists, we can write this as x minus 3 times the limit as n goes to infinity of 2n plus 1 over 2n plus 3. Now, certainly this limit does exist, right? As we've done many, many times today, we're taking the limit of a rational function, and we know how to do that. What does that limit turn out to be? 1. Yeah, this guy is 1, right? So we end up with x minus 3 times 1, or just x minus 3. Now, in order, and by the way, I made a serious error here. Absolute values all the way, right? Okay, now it looks better. Okay, now, x minus 3, that's not a set value, is it? It depends on x. So whether or not the related series converges depends on whether the absolute value of x minus 3 is less than what number, according to the ratio test? 1. So let me put it this way. So by ratio test, the given series converges for the absolute value of x minus 3 less than 1. Now, in the directions, you're asked to find the interval of convergence. It's an interval of x values. You guys know from Calculus 1 how to turn that kind of statement into an interval. How do you lose the absolute values? The absolute value of x minus 3 less than 1 is the same as saying x minus 3 is between what two values?
1 and -1.
Yep. And then if you solve that inequality, what do you get? Add 3 everywhere, right? So 2 and 4. So we're guaranteed if x is between 2 and 4, then that series converges. But wait, there's one more item I need to talk about before I let you go. What about the endpoints? What about 2 and 4? What happens there at those endpoints? So we do have to check for endpoint convergence. So what if x equals 2? That's the first thing we need to consider. That's the left-hand endpoint. Now let's go back and remind you what this series is. Here's the series. So just so that we can see it, let me put a copy of it here. Okay, there's the series. Now, if x is equal to 2, what do we get inside here? What does the series become? The sum from n equals 0 to infinity of -1 to the n. If x is equal to 2, what's 2 minus 3? Times, so we get -1 to the n times -1 to the n, all over 2n plus 1. So what does this become on top? Yeah, it becomes -1 to the 2n, or -1 to the n squared. It's always positive then, right? Now this diverges. This series diverges. How could you show that it diverges? I'm going to leave that conclusion to you. It's a pretty standard comparison deal, okay? But it does diverge. So at 2, we don't get, if x equals 2, we don't get convergence. Let's very quickly do x equals 4. So what does the series become if x equals 4? Just -1 to the n, right? Because this is just 1 to the n. When you plug in 4 right there, you just get 1 to the n, which is just 1. Oh, so -1 to the n over 2n plus 1. Now, I don't have time to show that it converges, but what test would you use? So this is what you get when x equals 4. It converges. What kind of series is it? Yeah, so you could show pretty easily it converges by AST, alternating series test. Okay, so then we would include the 4. So long story short, give me just 20 seconds. The interval of convergence goes from 2 to 4, including 4. So you would use a bracket around the 4. And the thing we call the radius of convergence, I'm going to call that R. The radius of convergence would be half the length of the interval, which is 1. Just go 4 minus 2, the endpoints, and then divide by 2. That's it.